Hi all, I'm Tim Vasquez here in North Texas, and we're looking forward to that eclipse coming up on August 21st. So the point of this presentation is to take a look and see if we can find the areas with the best sky conditions. And we can do that to a certain extent using historical data. So we're going to go back 20 years and try to find clues about what we will see for this eclipse event. Now, to really understand what's going to happen during the eclipse, we have to be smart about how we approach this data. If we're just looking at statistics and normals, that's not going to help us too much as we get within range of the models. We want to really understand what's going on within the atmosphere in terms of the systems. Now, normally in July, which is pretty much representative of August, we've got this large oceanic high-pressure area. And another one, this high-pressure area, it's called the Bermuda High. And we also have this low-pressure area out in the desert southwest, but in the Rockies. That's caused by very intense heating in the desert area and in the plateau regions of the western U.S. So what we get here is kind of a flow of air from the oceans into the land areas. Now, this particular area of flow right here, this is particularly strong and important, and we call that the southwest monsoon. That tends to bring up moisture into the interior regions west of the Rockies. And we also have the southerly flow coming up from the Bermuda High, bringing tropical air up into the eastern U.S. You can also see that on the Pacific coast, we tend to have cool air blowing inland. In this air offshore, we call that the marine layer, and normally it stays banked up against the coastal ranges, but sometimes it will make progress inland. Now, what you see here is a typical weather chart for July and August. And this shows the weather systems we usually see across the U.S. Now, what you see here is a surface system and an upper level high pressure area, or what we call high heights. And this is kind of in the mid and upper parts of the atmosphere. And you can see that not only do we have the monsoon coming inland, but that kind of couples with this upper level high, which rotates clockwise, and we tend to get this surge of moisture into the interior regions. Now, up in the northern U.S., we tend to get this progression of frontal systems, and this is not saying that we're going to have a frontal system in Montana, in the Dakotas, a low pressure area in Minnesota. This means that we're likely to have something like that going on. We may actually have the frontal system maybe out here with a low pressure area out in New York. But in any case, this is showing us that these frontal waves tend to move west to east through the northern tier states. And what that means is we might get northwesterly flow storms up in New York, but fortunately, most of the time, that's out of the path of that eclipse. And we also have to keep in mind the Bermuda High, which is lurking off the Atlantic coast. And that brings warm air up into the Gulf Coast area. And once that reaches the warm and heated land areas, we tend to get this little belt of air mass thunderstorms. These are storms that pop up in the midday till early afternoon. They continue through the evening and they dissipate during the evening. So if we put this all together with a track of our eclipse, we can see that there could be problems with fronts in Idaho, Oregon, and Washington there. Things tend to look okay most of the time in the interior northern Rockies, but some of that monsoon flow with the moisture and afternoon storms could affect parts of Wyoming, Idaho, and southeastern Oregon. Normally, In August, things are pretty good through the Great Plains into the Midwest area. But you can see that we do tend to have a problem with air mass storms anywhere from Nashville back to the Carolinas and Georgia. Now, of course, we can just go to the climatological information and look at what happened on August 21st each day, look at the cloud cover and plot it. And you can see that basically as you go east, you tend to have more problems. And basically anywhere from Tennessee eastward, there's a fairly decent chance you're going to have greater than half cloud cover, maybe up to 3/4 there. Meanwhile, back around Nebraska and Idaho, Wyoming, things do tend to be clear, sometimes all the way back into Oregon. And further west, you can see we definitely do have problems on the Oregon coast. You would definitely not want to be on the coast there. Portland is kind of on the fence there, and when you get east of the mountains into the deserts, things look a lot better. Now keep in mind that the eclipse will be visible throughout the entire U.S. This area, this little band that you see all over the internet, that's only about 30 miles wide, that is the path of totality. That's where the sun's disk is completely covered, 100%. However, the disk is partially covered elsewhere around the U.S., and in fact, along this outer line on either side, 70% of the sun will be covered. And that's definitely enough to see a very noticeable dimming of the sun. In this inner area, that's 90%. So that's very significant darkening of the sky there. And even if down in the South Texas area and Maine, 50% coverage. So that's a very good partial eclipse. Now, as far as viewing an eclipse, this is the May 2012 eclipse with my sun here. And it shows you can just use a pair of binoculars very easily. Use that to pass the sun's light onto an object, and you'll get a view like this. And what you're seeing here, that's the moon, and this is the sun. So all you need is a pair of binoculars, or you can basically use any pinhole. Just take a large piece of board, make a hole in that, and look at the image that projects onto the white surface. And you can see we used a very simple display to set up the binoculars. Put this on a very dirty car hood, and we were able to monitor every part of that eclipse. Now keep in mind, you never want to look directly at the sun unless you have something like a welder's helmet. There are invisible infrared rays, ultraviolet, that will damage your eyes. So do not try to stack sunglasses or use film to try to darken the layers. You need to indirectly project it like I showed you, or use special made goggles for that. Looking at Oregon, we have two main mountain ranges. We have the Cascades located here with some volcanic peaks, including Mount Hood, and we also have the coastal range located west of Portland. Portland is located right here, and this is the Willamette Valley. To the east, we have the interior high desert areas. Now, normally, Oregon stays pretty clear most of the summer. However, there is that marine layer off the coast, and there's that pressure gradient which tries to bring air inland but that air tends to be blocked by the coastal range. So for the most part, the cloudy, stable marine layer tends to hang around on the coast. Sometimes when there's a very strong gradient with very strong heating inland, the wind flow will increase from the west, and we would bring in some of the clouds through the passes and up the Columbia River like that. So usually Portland will start going cloudy, and some of these other stations, and then eventually, on a very bad event, it'll infiltrate the entire Willamette Valley area. In other cases where we have a lot of large-scale dynamic lift, the entire area will go cloudy. Here's a look at 20 years of cloud cover data, and we're going to focus on the western U.S. for this section. Now, a couple things you notice: the very strong tendency of marine stratus to reside along the coast. Sometimes it'll make it into this area right here, the Willamette Valley, and for the most part, the deserts will stay fairly clear. And 1997 was very average. 98 was a little bit worse. You can see Portland right there going under with almost overcast conditions. 1999 was also kind of questionable. A lot of cloud cover in Idaho. 2000 was a very good year. You can see clear skies everywhere. 2001 returned to kind of a dismal year. You can see a lot of cloud cover there in the Willamette Valley. 2002, again, kind of bad for Oregon. 2003, we have problems in Idaho. Pretty much overcast there. 2004, not too bad. 2005, another average year again. Same thing in 2006. For 2007, here we had a very bad year. A lot of overcast extending inland. Same thing in 2008, lots of overcast. 2009, a little bit better, but still just pretty much socked in right there around Portland and Salem. 2010, we kind of returned to a normal condition. 2011 was very good. 2012, again, the valley pretty much socked in there. 2013, we started to have problems in Oregon, Idaho. A very similar pattern again in 2014. Lots of cloud cover across this area here. Yellowstone, Jackson Hole, and Idaho Falls. And then for 2015, we returned to pretty average conditions. And 2016, that was one of the best years in the western U.S. If we had an eclipse a year before, would have been phenomenal viewing conditions. So on a very good year, this is how it looks in the western U.S. And you can see the marine layer, just extensive stratus off the coast. Meanwhile, inland, very nice conditions. And you can really see the stratus here in western Oregon trying to surge inland. 2016 was a very good year, so there was no chance for this to make it inland. But you can see where it's trying to snake in through some of the passes. Here's an example of a very bad year, and you can see a lot of Pacific air pretty much blasting right through the coastal range. The deserts stay, for the most part, fair, but you can see a lot of scattered or broken layers. The rippled fishbone appearance, that's indicating strong winds aloft. And here's another example of a very bad year, 2002. And you can see that some of the marine stratus made it inland, but this time it was stopped not by the coastal range, but by the Cascades. Here's another example of a bad day. This was 2002, August 21st, and you can see lots of stratus and fog there, but it's pretty much confined by the Cascades. So basically, if you head into the deserts, things look pretty good. So if there's bad weather in the Willamette Valley or Portland, heading east will probably be a good option. Now, for the key to what's happening, we look at upper air charts up at 30,000 feet. And these upper air charts are where the models are going to have the best accuracy 1 to 2 weeks out. When we look at the large-scale waves, you can see the height, or basically the pressure lines are kind of waving like that. These are very large-scale waves, and they kind of control the weather patterns at the surface, and these large-scale waves are fairly easy to predict pretty far out. So the model should start getting accurate within about maybe 10 to 14 days of that eclipse, and we can start looking at finer details. Now, this is an average year. This was 1997. We're looking strictly at the west coast for this half. And you can see we had a jet coming on shore. That shading is the stronger winds, and you can see the little flags here showing strong winds there. 1998 was another average year. Jet stream coming inland. 99. 2000 was a very good viewing year, and you'll notice something interesting. Northwest winds. And that's one thing that I found is kind of helpful for getting good viewing conditions. But another kind of indeterminate year was 2001. You can see a little bit of southwesterly flow there and an upper level disturbance coming through. Now, a bad year was 2002. So here we had a very unusual pattern. We had this really big wave and a big low pressure area over Washington and Oregon. Washington and Oregon located right there. So we had this big upper level disturbance right in the area. So bad viewing conditions and instability right there over the deserts. Another bad year, especially for Idaho, was 2003. And this is how 2003 looked. And you'll notice something interesting. South winds. Seems like when we have flow coming out of the south, things tend to go downhill. We're talking about winds up at 30,000 feet. Returning to kind of an average year was 2004. You can see that westerly wind coming in. 2005, pretty similar. 2006, a little bit of a storm system offshore, but winds kind of light. So viewing conditions were okay. Definitely better in the deserts. Then going to a bad year, 2007, and you see a very strong upper level disturbance over Washington and Oregon. See that shading there? That's a strong jet stream. Another bad year, 2008. Another jet stream. And then 2009, a jet stream in the area. Things were kind of bad along the coast and into Washington. And these strong jet streams, when they're impinging on the coast like that, they will tend to bring the marine layers inland. Returning to an average year, 2010. Well, we had a trough offshore, but they lucked out there. 2011, kind of a weak flow aloft, average, somewhat good viewing year. 2012, kind of average, but there was a trough in the area. And then 2013, this was bad for Idaho, and you can see the southerly winds. Another bad year for Idaho, 2014. And not so much southerly winds, and they kind of work close, but also a trough in the area right there. So apparently those troughs and southerly flow means bad news. 2015 was kind of an average year. You can see kind of light westerly flow. And then a very good year, 2016. And you can see we have westerly flow there in Idaho, or Idaho and Oregon, but also this little bit of ridging, which is a little unusual. So that kind of means high pressure, keeping things pretty clear there. Okay, for this segment, we're going to focus on the eastern U.S., basically east of the Rockies. So we're looking at cloud cover at around 11 a.m. on August 21st, this time 1997. So you can see some problem areas right there in Illinois. For 1998, pretty good conditions in most areas except the high plains right there. Good conditions in 1999. 2000, problems right there in the Nebraska, Iowa area. And you'll notice that we have cloud cover across South Carolina and Tennessee. And this is a problem area that we have to watch. 2001, things looked pretty good. Also, no real problems in 2002. 2003, a little bit problematic there in Tennessee and the Carolina area. 2004, okay, this was a bad year. You can see a weather system through Tennessee, keeping things pretty overcast there. 2005, pretty decent year. 2006, some problems there in Tennessee. Nebraska and Missouri looking pretty good. 2007, Tennessee again having a few problems. 2008, a big weather system across the central U.S. 2009, again, we're having problems in Tennessee. A little bit of overcast there in the Carolinas, but you would probably find some decent viewing conditions somewhere. 2010, now we have some problems in the Carolinas. 2011, some problems in that same area, eastern Tennessee and the Carolinas. 2012, very nice viewing conditions. 2013, okay, we're having those problems in that same area again. 2014, good conditions. And then 2015, there's those clouds again. And then 2016, even more clouds. So what is the problem? What do we need to be looking for? Well, again, we go to the upper air charts. So here's 1997. This was a fairly decent viewing year, except for maybe Tennessee. Northwesterly flow. That seems to be associated with some decent viewing conditions. So when you have the trough, upper level low out east, and a ridge, high pressure out west, that seems to be very good for eclipse viewing weather. And another good year was 1998. So it looked like we had a little bit of high pressure across the eastern U.S. Another good year, 1999. Again, there's that northwesterly flow. Now, a bad year was 2000. Now you can see, yeah, there's a few problem areas here or there, but the eclipse path looking pretty good, and the south also. Plenty of clear skies down there. Okay, so what happened in 2000? Well, we did have a little bit of northwesterly flow. However, it's hard to say. There probably was some moisture in Tennessee and South Carolina, maybe coming northward. We can't really tell from this chart. But what we can tell is that the good northeasterly winds are not hitting the areas that we're concerned with. But what we can tell is that the northwesterly flow is not as large and deep as it needs to be there. 2001, this was kind of an average year. 2002, pretty much the same. You can see light winds across the eastern U.S. 2003, conditions were kind of bad across Carolinas and Tennessee, and I think kind of a recurring problem is when we have light flow aloft, and I think that causes some of the moisture to kind of stagnate and tends to accumulate. Moisture sources would be evapotranspiration, and probably what that does is help feed thunderstorm activity. 2004 was bad for the Midwest and the plains. And you can see an upper level trough is in the area. So that's one thing to watch out for, a trough axis right over the viewing conditions. And the satellite picture looked like this, and you can see if the eclipse happened that day, there would be a lot of problems in Tennessee and some areas having problems in the Carolinas. A lot of haze, especially in that area. So what we're seeing here, we can tell that there's a front in the area. There's all this clear air. This is air coming from Canada moving southward. So the front is over the Tennessee area on this day. And also the Appalachians, orographic effects. That's helping to create lift, and we're getting showers going in the mountains right there. And that, in turn, is producing debris, like anvils, going up, spreading out at the top of the troposphere, and creating a lot of overcast in this area. 2005 brought pretty decent conditions, and nothing that really stands out there. Now, 2006, bad problems for Tennessee. And again, what we see here is light flow across that area. I do see a little bit of ridging aloft, but apparently we had a lot of good low-level moisture in the area. 2007, a very good year. You can see very light flow. 2007, a very good year. Looks like a fairly good fetch of light westerly flow across that area. 2008, bad for the Midwest and the Carolinas. Well, we had an upper level trough across the Midwest into Nebraska. And over the Carolinas, we have this high pressure area with light variable winds. So I think that may be a culprit there. 2009, bad weather for Tennessee. Looked like they were in the base of a trough right there, this big upper level trough right there. However, good viewing conditions in Nebraska, and they had very deep northwesterly flow coming down. 2010, kind of a marginal year. 2011, a good year. You can see the good northwesterly flow there. I don't have the chart for 2012, but 2013 was a bad year, Tennessee and the Carolinas. And I'm not too sure if we can tell anything from this chart. However, there is a southwest flow there. So I suspect, that's a little bit unusual. So I would be concerned about that. 2014 was an average year, a little bit of a problem in Tennessee. 2015, bad for the Carolinas. Looked like they were under this upper level ridge. So I think that might be a problem there, maybe a little bit of air mass stagnation, and also a little bit of a southerly component, winds from the southwest flowing to the northeast there. And then 2016, bad for Tennessee. Again, a little bit of a southerly component to the winds aloft there. But you can see that even on a good year, plenty of moisture there in the Carolinas, into Georgia, and we get these cumulus fields going up during the afternoon. Now, these aren't going to cause too much of a problem. They're going to blot out the sky for maybe a few minutes, and then a few minutes of sun, a few minutes of overcast. And you can see about 40 to 50% coverage here. So that would not be a showstopper, but it would kind of curb the fun a little bit there. So in the Carolinas, what I would look at doing with the pervasiveness of all this cumulus cloud cover, even on a good day, I would probably go and look at the high-resolution rapid refresh model, the HRRR. So to get there, what you're going to do is put NOAA HRRR in your browser and just click on what it gives you. That'll take you straight to the site. And what you're going to do is click on INCEP HRRR hourly right there. Then when the page comes up, you're going to change the domain to Southeast. Then you're going to scroll down. If these fields are not populated, what you're going to do is bring the date back and pick an earlier run time. And this is what time the data was based on for the model in UTC. And you can see that if you wanted to go out further, you would have to go back like this. And that's only going to take you out maybe 18 to 24 hours at best. Now what you're going to do is go down the list and find where it says low cloud cover. And I'm picking that specifically, not the total cloud cover, because I want to look strictly at that cumulus. You know, there could be a little bit of error with a high cloud. You can definitely look at that separately and see what you think about that. But low cloud cover, you just click on that. So what you would do is you would try to stay away from areas where you see higher values. I would not put this under a microscope and try to use it that way. But you, looking at this, for example, if this was the actual forecast, you would want to target this area and try to stay away from these areas, for example. Now another tool you can use is the relative humidity. And you're going to use the 850 millibar relative humidity, or if you know of a site that has 925, use that. And here you can see higher values of relative humidity in this purple area, and that would indicate a greater likelihood of clouds and haze. So if I saw this, I would probably not want to go to this county specifically, but maybe look at this area in the northwest part of the state. And here's another example of a 850 millibar relative humidity chart. 850, that's 5,000 feet. That's about the height of the cumulus layer. Sometimes it overshoots the cumulus, so that's why I try to look at lower layers. But here's another example. This would indicate more cumulus along the coast, more broken to overcast, and then probably better viewing conditions in that part of the state. And that's assuming that this was the forecast for that area on that date. But we're not going to know until August 20th. And then finally, these frames will be in range of the mesoscale models. Now, you can use this website, of course, for the plains. And I was emphasizing the Carolinas there with their persistent cumulus problem, but this site is definitely useful for elsewhere, the Midwest and the Great Plains. And to get to the Great Plains, you can just pick South Central or North Central U.S., and the chart sets will come up for that area. So here's an example of low cloud cover for the Great Plains, and you would just compare that with the track of the eclipse when that happens. So again, using this product, you're not going to want to like focus on this area and that area and so on, but maybe look at the big picture. Maybe consider all three of these areas as good candidates and try to avoid like this area, for example. Because the model is not that good at picking out minuscule details like that, but at the 10 to 50 mile range, it's actually pretty decent. So here's the model charts we have of the morning of the eclipse, August 21st, 2017. This is a model run from July 26th. So this is a 624-hour forecast. And this far out, the model run is basically garbage. But as the model gradually starts converging on the date, about 1 to 2 weeks out, sometimes 3 weeks, some of the larger indicators will come into, will kind of like lock into place. Now, just to show you how much variability there is in the forecast, I'm going to run this through from the July 26th run to the 27th, to the 28th, to the 29th, and watch how much flip-flopping there is of the solution. This is the 300 millibar pattern up at 30,000 feet. But one thing that is kind of persistent is this idea of a trough in the northwest. It's almost always there. See, there it is again. We're up to the 30th. Kind of some large-scale long-wave troughing. More troughing there on the yesterday's run. And then last night's run. This is the latest I have. Large trough across British Columbia and westerly flow. And then it shows a ridge out over the eastern U.S. So I'm not too sure we can tell anything conclusive for this because 516 hours is still way, way out there. But as we start getting closer, I would look at the long wave pattern, like the large waves, not like the little ones you see here or here. I would look at the large waves like that. So basically, trough to the west, ridge to the east, and that means southwesterly flow for the western U.S. So I think we're risking below average viewing conditions in this area at first glance, and out east it's kind of indeterminate. But there is an absence of that nice northwesterly flow, so there could be problems out into the U.S., the eastern U.S. itself. But again, there's only a very, very slight probability that it will actually work out the way I'm saying. But for now, that is how it looks. So this is kind of for the advanced viewers, but this is a matrix where I've worked out some of the forecast indicators, and this goes by year and from west coast to the east coast. And I've kind of grouped this into low level and upper level. And this doesn't mean like here ridge to the west. This means a ridge present with westerly flow. And then I've got some climatological teleconnection indicators. I haven't really found anything too conclusive with that. In fact, we're in an El Nino neutral period, so that doesn't really mean very much. However, it does seem like there is an association with the PNA index, and when it's positive, that's usually implying a trough in the eastern U.S. And it seems like when that's the case, We do get some worse days in Tennessee and Kentucky, and to a less extent maybe the Carolinas, but mostly Tennessee and Kentucky there. So what I've found is for most of the U.S., northwesterly flow at the upper levels at 300 millibars is good for viewing conditions. Bad would be flow out of the southwest. And it does seem like in most areas, southwesterly flow in the low levels is kind of tied to worse than average viewing conditions. Also, a warm air advection pattern in the lower levels is bad, and that's associated with isentropic lift and moisture advection. So that brings us back to this map, and what that pretty much tells us is maybe these shaded sites indicating clouds, maybe that will actually happen. A little less uncertain in the Great Plains and the Midwest, but the best chances of clear air look to be there. So I think probably Nebraska and Wyoming do look to have the best probability for good viewing conditions. Now, my other advice would be, if you're out east, avoid the Appalachians. Not only do you have winding terrain and problems with enough roads, you have orographic lift, a lot of sources of lift out there with all the hills and higher terrain. So that is going to locally boost the cloud cover in that area. So you'll want to get out to some of the flatter terrain, maybe try to go to perhaps the Central Carolinas, or head into Tennessee itself, up into Ohio and Indiana. If you're heading for Missouri, my advice would be to try to get west if you can, because the better odds are going to be to your west. But at this point, we just don't really know for sure how it's going to play out. For Nebraska and Wyoming, I think you're good. There's nothing to do. We just wait until the week before the eclipse. And then, if you're in Oregon, I would try to get out east into the deserts. The Willamette Valley, that could go either way. As you've seen, it's about a 50-50 shot that they will get clouded over. But the good news is, if we are expecting that, you should be able to just go east across the Cascades, and the desert will give you a little bit better viewing conditions. If there are clouds, they're more likely to be mid and upper level clouds, which are, of course, more transparent. And then the coast, personally, I would not risk that. But, you know, there may be some breaks out there. It's not a solid overcast sheet, and you can always go up into the hills around there, and the stratus layer is very low, only a couple thousand feet off the ground. So it is possible to get into the higher terrain, maybe through some of the back roads, and get above that. So I hope you enjoyed that forecast of what's going to happen on August 21st, and I'll definitely be heading up there myself. Please check out my nightly weathercast at 8 p.m. Central. That's at youtube.com/TimWXX, TIMWXX, and we have a very interesting presentation on forecasting, and you can participate and chat with the people we have in there. And I hope I will see you there, and we will be covering this event as we get closer to August 21st. So good luck, and here's hoping for clear skies.